The capital of India, New Delhi, is home to 1.9 crore people living in an area of 1,484 square kilometers. The bustling metropolis is a representative of the country's growth and progress. The city has a network of 1,749 kilometers of road length per 100 square kilometers. Delhi has one of the highest road densities in India. Major roadways include the Ring Road and the Outer Ring Road, which had a traffic density of 110,000 vehicles per day in 2001, which has exponentially grown over the last 2 decades. Total road length of Delhi was 28,508 kilometers, including 388 kilometers of national highways. Major road-based public transport facilities in Delhi are provided by DTC buses, auto rickshaws, taxis, and cycle rickshaws. Delhi Traffic Police manages the flow of traffic in the capital, and an integral part of traffic management are traffic signals, commonly referred to as red lights. You may pass many of these around the city during your commute, but have you ever thought how these signals function, how are they managed and controlled? Delhi is divided into 53 traffic circle jurisdictions having close to 1,000 signalled intersections. The traffic circles can also be categorized into the following districts: North, Northeast, Northwest, South, Southeast, Southwest, Central, New Delhi, Dwarka, and Outer. The traffic signals are coded from letters X and Y, AN, PR, and S. Each letter code represents a corridor and/or connecting roads. Any traffic signal in the city can be spotted on this map developed by Mapping Section of Delhi Traffic Police, available on the Traffic Police's website. Onyx Electronics, a Delhi-based company, has been involved in the business of traffic management systems and solution. They have over 17 years of experience in design, manufacture, installation and maintenance of traffic signals, including complete hardware and software. Let's hear from the CEO and founder of Onyx, Mr. Jitendra Kaushik.
Hello, I am Jitendra Kaushik. I am founder and CEO of Onyx Electronics Private Limited. We are involved in the business of intelligent traffic management system. All over the country, we are manufacturing equipments, designing systems, installing and doing the operation maintenance of such systems all over the countries, including all the smart cities, major smart cities. How Onyx came to the business of intelligent traffic management system is also very interesting. As a road user, those days I used to drive a motorcycle. There was an anxiety to know when the traffic signal will turn green while it is red. For this purpose, there was no device because it was only red and green and yellow light. A device was required which I designed and promoted in the country. The device was countdown timer, which released the anxiety in how much time the signal will turn red or it will turn green, and saved a lot of petrol.
A basic traffic signal has 3 main lights: red, amber, and green. Along with this, we have countdown timer in almost all traffic signals, which count down the time until the next signal change. The green signal can also have turn signals giving the right of way for vehicles turning left or right on an intersection. All of the signals at a junction are managed by a traffic signal controller further connected to a central control. Onyx has developed signal-wise chart showing the positioning of traffic signals, their blinker timings and time changes for each signalized intersection in Delhi. This chart for junction E72 shows its name, code, district, circle, signal positioning, plans, their timing and total cycle time. The plans differ from junction to junction depending on its location, the amount of traffic it handles every day. Different plans are run on public holidays and non-working days as the flow of traffic is comparatively less. Different junctions function differently depending on their location, the amount of traffic moving through that area, and other factors. For comparison, this complex junction, K26, located in Patel Nagar Circle, has multiple signals to coordinate traffic from different directions, has no holiday plan, and the total cycle times exceed 100 seconds. E62, located in Punjabi Bagh Circle, has a holiday plan and the cycle times are lesser than that of junction K26. Every signal has the signal code written on it. E72 is the junction code. 4 is the placement of this signal in this junction, which can also be seen in the chart. Each signal functions according to the plan from 6 am till 11 pm. They switch to amber blinking mode at that time as the traffic isn't that heavy, requiring a signal plan to be run. Some junctions on important roads would still function on plans. This decision making is done by the traffic in charge of that particular region. E21, located near Multan Nagar in Punjabi Bagh Circle, is one such example. The signal plan doesn't change to blinker at 11 pm so that it can handle the heavy traffic that plies on Rohtak Road, one of the main roads used by vehicles passing through industrial areas of Delhi. There are places where blinkers are installed along with regular signals. For example, a part of X37 on Ring Road is this blinker, which alerts the vehicles for traffic taking a U-turn and merging in their direction. Another technology used for safety purposes are Pelican Signals, Pelican being the acronym for Pedestrian Light Control Activation.
Traffic signal is used to give a right of way. It means if there is a 4-arm intersection, traffic is coming from all the 4 arms. Now, traffic should be stopped for 3 arms and right of way should be given to 1 arm of the intersection. For this purpose, a small industrial computer is used. We call it traffic signal controller, which is there at each intersection. Wherever traffic signal has been installed, you find a traffic signal controller. And the controller decides which arm will show a green light and which arm will show the red light and for how much time.
More than 50% of the signals are operated manually during peak hours. Because it is not possible to manage the traffic at that time unless we have a very sophisticated system, with the help of a police panel on the signal, the person switches the signal from auto to manual mode. Now, with the help of a button, the next signal can be turned green until the button is pressed again. When the police officer feels the peak hour is over and there's no more need to manage the signal manually, the switch is toggled back to auto mode. The signal plan can be fed into the signal in a number of different ways. Number 1, a keypad connected with the signal itself can be used to input the required timing. Number 2, a laptop can be connected with the signal with the help of GUI to easily create the plan and then input it into the signal. And number 3, with the help of network connectivity between our location and the signal, we can input the plan remotely into the traffic signal controller. The next step is vehicle detection based traffic signals using video analytics. The system first detects the presence of any vehicle in that specific area, and if there are vehicles in the region, the light will stay green for that moment. This video analytics also helps in gathering data in terms of number, types, and classification of vehicles plying on the road. Here is a clip showcasing the vehicle actuated traffic signal at KG Firoz Shah Marg. There are various corridors in Delhi's road network. The traffic signals in the particular corridor can also be ran in synchronization with each other. In theory, this would mean that maintaining an average speed of about 40 km per hour or so, all the signals throughout the corridor would be green and you won't have to stop at a signal. However, in practical applications, 100% success isn't guaranteed owing to various factors.
स्पीड कैमरा लगाना सबके लिए बहुत यूजफुल रहा है. कारण बोलता हूँ, पहले हमेशा दिल्ली में सब जगह स्पीड लिमिट 40 किलोमीटर पर आवर लिखी होती थी, जो प्रैक्टिकल नहीं थी. लेकिन पुलिस की भी मजबूरी थी, उनके पास कोई सिस्टम नहीं था पता करने का या चलानी करने का. ये स्पीड कैमरा आने के बाद पुलिस सिस्टम भी इवॉल्व हुआ है और अब बहुत सारी जगह ऐसी हैं जहाँ पर दिल्ली में 50 किलोमीटर, 60 किलोमीटर, 70 किलोमीटर ऑल्सो इज द परमिटेड स्पीड लिमिट. इससे लोगों को फ़ायदा ये हुआ है कि अब वो गिवन स्पीड लिमिट में रहते हुए भी समय से पहुंच सकते हैं. पुलिस को फ़ायदा ये हुआ है कि वो चालान कर सकते हैं उन लोगों का जो स्पीड को वायलेट करते हैं या ट्रैफिक पुलिस के नियम नहीं मानते. जहाँ तक इसकी प्रैक्टिकलिटी की बात है, ये बहुत बढ़िया सिस्टम है, लेकिन इसमें बहुत सारी कमियाँ भी हैं. जैसे दिल्ली के रोड यूज़र्स भी बाकी शहरों के रोड यूज़र्स की तरह स्मार्ट हैं, बहुत स्मार्ट हैं. उन्हें पता है कि स्पीड कैमरा कहाँ लगा हुआ है. जब स्पीड कैमरा पास में होता है तो सभी लोग अपनी स्पीड उस गिवन स्पीड से नीचे ले आते हैं और जैसे ही वो स्पीड कैमरा क्रॉस होता है उसके बाद वो सब फिर दोबारा से ओवर स्पीडिंग करना शुरू कर देते हैं. ये इस सिस्टम में कमी है जिसका इलाज विद टाइम निकलेगा. जब सिस्टम भी इवॉल्व होंगे, पब्लिक भी इवॉल्व होगी, ऑफिसर्स भी इवॉल्व होंगे।
The Delhi Traffic Police Headquarters, located in Todapur, deals with the management and planning of traffic and traffic signal related management in Delhi. Located inside the complex, the Traffic Engineering Branch, Signal Cell, Control Room communicate amongst each other and companies such as Onyx, who manage and maintain these signals and systems on the ground. The Traffic Police also has a specialized Accident Research Cell which manages road accident related data and prepares maps, infographics such as this one from 2014 showing accident prone zones across Delhi. The current traffic management system in the city is functioning at its maximum capacity. There are gaps in the system that need to be bridged with the ever-growing need for faster, reliable and safer road transportation solutions in the city.
Future of transportation system in India, in all the cities, is going to drastically change. अगले 3-4-5 सालों में ही सब कुछ बहुत तेजी से बदलने वाला है। जो सरकार है वो बहुत ऑफबीट है नई टेक्नोलॉजीज़ के लिए। जो यूज़र्स हैं हमारी कंट्री में, जो यूथ है वो बहुत ज़्यादा इंटरनेट यूज़ करता है और टेक सेवी है, और दुनिया भी 5G टेक्नोलॉजी के साथ तैयार है। तो आने वाले समय में जब यहाँ पर V2X, V2V मतलब व्हीकल से व्हीकल के बीच में कम्युनिकेशन, व्हीकल से ट्रैफिक सिग्नल के बीच में कम्युनिकेशन, इस तरह से ये 5G सिस्टम जब आ जाएगा तो यहाँ सब कुछ बदल जाएगा। इतना मेजर चेंज होगा जो पिछले 50 सालों में चेंज नहीं आया है, जो अगले 3-4-5 सालों के अंदर चेंज होने वाला है।
The Ministry for Electronics and Information Technology and CDAC, Center for Development of Advanced Computing, organized a conference on Intelligent Transportation System Endeavour on 7th and 8th April 2022 at India Habitat Centre. The event, Intelligent Transport System Endeavour for Indian Cities, was attended by eminent academicians from the field of civil engineering, transportation, IoT, etc., along with dignitaries from IIT Bombay, IIT Madras, and IISc Bangalore. CDAC launched 3 new technologies. The system intends to integrate intelligent driver assistant systems on commercial vehicles, which is now available only in luxury vehicles, radar sensor employees, millimeter wave technology to detect and monitor nearby vehicles and obstacles, giving the driver a greater sense of their surroundings. Signal priority is an operational strategy that facilitates the movement of in-service buses through signalized intersections. The system developed in this study is to minimize person delay by providing priority to public transport. Cosmic Connective is an end-to-end common service platform developed by CDAC for integrating diverse lot devices and applications to interact with a common global one M2M standard onto the smart city framework in order to achieve interoperability among lot devices and applications. One of the keynote speakers, Dr. Satish V. Ukusuri, Riley Professor of Civil Engineering, Lyle School of Civil Engineering, Purdue University, USA, shared how data collecting and transportation based around the way road users behave, interact, and engage with transportation technologies. The prospects, challenges of AI in transportation systems was also discussed by Professor H.P. Khincha, advisor IISc Bangalore. All of these key organizations in the nation are already ahead on preparing the best possible, reliable and safest system for all road users. It is upon us, the common folk, to respect these systems, respect the organizations undertaking the mammoth task of keeping these systems up and running on a daily basis, and travel as responsible citizens of this country.